2018 number 3, this is another classic type problem where I see a graph that is made up of line segments, and sometimes there will be a semicircle. In this case, it's a parabola, but that tells me that I'm going to be finding areas geometrically, and I just know that from the start. And so it tells us that this graph is g, which is the derivative of f. So, pay attention to what you have a graph of. It's the function g. It's also f prime, the derivative of f. Okay, and it says that g is piecewise linear. So that just means that these are all line segments from -5 to 3. And then it tells you a function for 3 to 6, and that's the parabolic part. So you're never going to have to find a function to describe, some kind of curve. They're going to either, if it's a curve, they're going to give you the equation. And, otherwise, if it's semicircles or line segments, you're not going to find an equation. You're going to use areas, or if it's asking about the derivative, you're going to use slopes. So you never have to, when they give you a graph, you never have to find an equation for the graph. All right, so now what are they asking us to do? They're asking us to find f of -5, and when we know f of 1. So should right away, they give you one value, they ask you another, they gave you f prime. That should get you thinking about the fundamental theorem of calculus in the accumulation form. F of b equals f of a plus the integral from a to b of f prime of x dx. And f prime is what we have a graph of. So now we can just plug in our values. Now, some people, by the way, will say, since we're looking for f of -5, let's have -5 be the b and 1 be the a. But then you're going to have integral from 1 to -5. You're going to have to flip the integral over. Some people do it that way. I like to just always have b be the larger number, regardless of which one is known or unknown. So f of 1 is 3. So let's do b is 1 and a is -5. So then we're going to say that f of 1 is equal to f of -5 plus the integral from 1 to 5 of f prime of x dx. I know what f of 1 is. They told me it's 3. So f of -5 is what I'm solving for, so I'm just going to leave it. And now I have to figure out what that integral is from -5 to 1, right? It's from -5 to 1. Oh, why did I write this? It's -5 to 1. I always got to screw something up. So that's -5 to 1. Okay. So if I'm doing the integral from -5 to 1, I just look at areas. So the first thing I see is this rectangular area. It's below the x-axis, so I want to make sure I use a negative. It's 3 by 3, so that's -9. And then I have this triangle. It's also below the x-axis, so -3/2. This part that just goes along the x-axis has an area of 0. And then this is a positive area of 1, because 1 times 2, 1/2 of 2 is 1. So that's going to be +1. All right, so now I can solve for this nicely, but by the way, you're certainly within your rights to say this is just going to be 3 plus 9 plus 3/2 minus 1 equals f of -5, and that's it. I'm done. I can just leave it like that. So especially if this is a calculator, this is a no calculator question. Of course, you're not going to have no calculator questions, but still, I could have typed this wrong into my calculator, somehow missed it. So it's pretty advantageous for me to just leave it unsimplified, especially if I'm not going to use this later. But by the way, it's 12.5. All right, but you can just leave it like that for that part. And that's part A.